A city transportation office wants to understand how far people commute to work each day, so they can think more clearly about traffic patterns, congestion, and public transportation needs. Their goal is not to judge anyone's commute or decide whether a commute is good or bad. Instead, they want to answer two practical questions. What does a typical commute look like for most people? And how much do people's commuting experiences differ from one another? To explore this, the office surveys a small group of people and asks one clear, measurable question. How many total miles do you commute each day? The responses they collect in miles are 5, 6, 7, 7, 8, 9, 10, 10, 11, 12, 13, and 40. Because these values represent miles traveled, they are numerical data. This matters because numerical data can be ordered from smallest to largest and summarized using calculations like mean, median, range, and standard deviation. If the question had instead been, what is your main way of getting to work? And the answers were car, bus, train, or bike, those would be categories rather than measurements. In that case, calculations like mean or median would not make sense, because categories cannot be added or averaged. Here, however, the values are numbers with real size and distance, so these calculations are appropriate. Placing the commute distances in order helps make the pattern visible. 5, 6, 7, 7, 8, 9, 10, 10, 11, 12, 13, 40. Most of the values are close together, ranging from 5 to 13 miles. One value, 40 miles, is much larger than the rest and clearly separated. In everyday terms, this one commute is very different from everyone else's. In statistics, a value like this is often described as an outlier. An outlier is not automatically wrong. It may represent a real person with a very long commute. However, it is important because it can strongly influence certain statistics. To describe what is typical, the transportation office considers several different statistics, knowing that each one answers a slightly different question, and that some are more appropriate than others depending on the data. They begin with the mean. The mean is the average. It is found by adding all the commute miles together and dividing by the number of people. For this group, the mean commute distance is about 10.7 miles. In real-world terms, this means that if the total number of commute miles could somehow be shared evenly across everyone, each person would commute about 11 miles per day. This interpretation helps make the mean concrete. It represents an equal sharing of the total distance. However, the office does not stop there. They know that the mean is sensitive to extreme values. The 40-mile commute is included in the total, and because it is much larger than the other values, it pulls the average upward. This raises an important question. Does the mean actually describe what most people experience, or is it being shaped by one unusually long commute? To answer that question, the office looks at the median. The median is the commute distance of the person in the middle after lining everyone up from the shortest commute to the longest. With 12 values, there is no single middle value, so the median is the average of the 6th and 7th values. In this ordered list, those values are 9 and 10, so the median is 9.5 miles. In real-world terms, the median tells the office that about half of the people commute less than 9.5 miles, and about half commute more than 9.5 miles. This interpretation is especially helpful because it describes a typical person rather than an overall total. Unlike the mean, the median is based on position, not size. The 40-mile commute barely affects it. When one value is far away from the rest, the median often gives a better picture of what a typical person experiences. And that is exactly what is happening here. The office also examines the mode. The mode is the value that appears most often. In this data set, 7 miles and 10 miles each appear twice, so there are two modes. In real-world terms, this means the most common commute distances in this group are around 7 to 10 miles. The mode is useful here because it reinforces what the median already suggested. Most people commute a moderate distance. Mode is always appropriate for categorical data, such as identifying the most common way people travel to work. For numerical data, it is only helpful when values repeat. If every commute distance were different, the mode would not add useful information. The office briefly considers the midrange. The midrange is halfway between the smallest and largest values. The smallest commute is 5 miles and the largest is 40 miles, so the midrange is 22.5 miles. When the office compares this number to the data, it quickly becomes clear that it does not represent anyone's experience. Almost no one commutes anywhere near 22.5 miles. This shows why midrange is often not appropriate when an outlier is present. The midrange depends entirely on the extremes and ignores where most people actually fall. Describing what is typical is only part of understanding the data. The office also needs to know how much commute distances vary from person to person. Two groups can have the same typical value but very different levels of consistency. They begin by calculating the range. The range is the largest value minus the smallest value. Here, that is 40 minus 5, which equals 35 miles. In real-world terms, this tells the office that commute distances in this group span 35 miles from shortest to longest. While this shows the full spread, the office also recognizes a limitation. The range is completely shaped by the two most extreme values. One unusually long commute makes the range large, even if most people are fairly similar. To understand typical variability, the office looks at the standard deviation. Standard deviation describes the usual distance values fall from the mean. In this dataset, the standard deviation is about 9.2 miles. In everyday terms, this means it is common for people's commute distances to differ from the average by several miles, not just 1 or 2. Because 9.2 miles is large compared to the mean of about 10.7 miles, this tells the office that commute distances are not very consistent across people. It also means the average commute distance is not a strong predictor of any one person's commute. To make the effect of the outlier even clearer, the office temporarily removes the 40-mile commute and looks again at the remaining values. 5, 6, 7, 7, 8, 9, 10, 10, 11, 12, and 13. Without the outlier, the mean drops to about 8.9 miles, and the standard deviation becomes much smaller. This comparison shows exactly what outliers do. A single extreme value can raise the average and inflate the standard deviation, changing how the data are interpreted. When the office visualizes the data using a box plot, the same story appears visually. The median sits among the clustered values, the middle portion of the data is fairly compact, and one value stretches far beyond the rest. This visual reinforces why the median better represents a typical commute, and why variability appears high when the outlier is included. In everyday language, the meaning of this data is clear. Most people in this group commute between about 7 and 12 miles each day. A typical person's commute is closer to 9 or 10 miles than to the overall average of about 11 miles. One person commutes much farther than everyone else, and that long commute changes the average and increases overall variability. By choosing statistics intentionally and understanding what each one represents, the transportation office can explain what is typical, how much people differ, and why some numbers are more useful than others for describing real-world experience.